Hello everyone and welcome to Probability and Statistics. We're working with a normal distribution problem right here for continuous random variables. So you can go ahead and pause and read this problem if you want to, or skip ahead as I read it. Wheel throwing, firing. The time of wheel throwing and the time of firing are normally distributed. So there's your normal distribution right there. Random variables with means of 40 minutes and 60 minutes and standard deviations of 2 minutes and 3 minutes respectively. What is the probability that a piece of pottery will be finished within 95 minutes? So this is using multiple random variables in order to find the probability of a single outcome. So we're looking for the first one. We're looking for the probability of x plus y being less than or equal to 95 minutes, basically. So that's what the problem is asking for part A. So we're going to call x, we're going to call it throwing. I'm going to call y equal firing. So then mu of x is equal to 40 minutes. Sigma x is equal to 2 minutes, the standard deviation. So then sigma x squared, which is the variance, is 4. And then mu y is equal to 60 minutes. Sigma y is equal to 3 minutes. And sigma y squared, of course, is equal to 9 minutes. So we've got all the information that we can possibly get from the problem now. So go ahead and solving this. We're going to have to find the probability. This is going to translate the probability of z less than 95 minus 100, 100. What did I do right there? 95 minus 100 all over 13 to the point 1/2. And this is the equation for z within for a normal distribution. So whenever you have a normal distribution problem, you just automatically go to the c problem basically. And since we're doing less than, you can call this less than or equal to. You immediately transfer x plus y, which we can call it, I don't know, let's call it w, which then translates into z when you start using the normal distribution. So if you solve this out, you should end up with 1.39. And then if you look up the z in the table of the back of your book that you have, I don't know which table you're using for your book, you should end up with this probability equal 0.0917. So you've got about a 9% probability of pottery being done in less than 95 minutes. Okay. So now, let's do a little harder one. The probability of x plus y being greater than 1/10. Okay, this one's a little bit trickier because since x plus y is greater than 1/10, we don't have a finite limit on x and y, so there's no upper bound for this problem. So what you have to do is rewrite this basically as the 100% all values minus the probability of x plus y less than 1/10. Because if you think about it, if you've got something that goes off to infinity, I like to draw kind of a cup like this. If you're filling this up with water, you can fill it up forever and ever because there's no upper bound. So what you have to do is if 100% is in infinity, 100% at equal to infinity, well, you can't very well integrate over or use infinity to find this problem because there's no limit there. There's no finite value that you can use. So what you do is if you're going from here to infinity, well, all of it has to equal 100%. So if you take 100% and subtract this part, then you will get this level to infinity. So that's why you have to do 1 minus the probability of x plus y less than that. Just flip the signs and subtract from them. Okay, so if you go ahead and solve that out, you get 1, the probability of z less than 1/10 minus 100 all over 13.5. And the 13 basically comes from the sigma x squared and the 9 added together, if you didn't know where that was happening. Okay, and then this should equal, taking this will go to 0.997 0.9972. After looking up the z, the actual value of this is 2.774. Solving this will give you 2.774. You look that up in the table, it'll give you 0.9972. So then 1 minus 0.9972 is equal to 0.0028. And that's your probability of the firing taking longer than 110 minutes. And that's pretty much all there is to it for a conditional probability with a normal distribution. Hopefully within the problem they will tell you whether it's normally distributed or not. If you don't understand how these work, watch a couple of my other videos, and I have a few where I explain normally distributed or bivariate and that kind of thing, or binomial distributions and all that kind of thing. And the only thing that changes is basically this equation for z. But other than that, the process remains the same. You just go ahead and take the probability, put it into a z equation basically here, find the z, and then solve for it. And that's all you got to do.